I would like to go for, let us say that visualization. As I said, whenever we want to visualize, visualization happens at three levels. First, basically, is we would like to see how the distribution is looking like. Do you know what is meant by distribution? Any idea? Because generally the way we try to learn is we should ask the question, do I know this concept? In whatever fashion you have, don't worry about being wrong. Because one of the things that I would like to remove from this team, if the only thing I do from this session is removing the question capability or confrontation capability, I am happy, right? So that's enough. You should confront, you should say I don't know, that's okay, but you can never say I don't know. You know distribution in one way or the other. You know distribution. What is distribution? Just take the corona distribution, right, across the states. How is the distribution? Within the state, how many are there? Whether they are coming from outside, whether they have the contact with the people who are coming from outside, or that's a tertiary contact, that we will keep as a separate one, right? Now, as of now, from the states, how it looks like? It looks like an inverted curve, isn't it? The curve looks like this, right? Do you agree? The curve looks like this. The curve looks like this, something like this. So this is a distribution. So how it is being distributed, that will be understood only when we plot it. So when we plot it, we get the distribution, and that is what we call as the base knowledge. Right. Now let us take population of India. What is our understanding? How many kids are there who are below 15? How many people are there between 15 and 25? How many people are there between 25 and 60? How many people are there between 60 and 80? How many people are above 80? The moment you have the answer for this, you know you have the base knowledge about the Indian population, at least their age, isn't it? Right? So as data scientists, as business analytics professionals, it is necessary that we establish base knowledge for our own business. Whatever the business that you are in, you should collect the base knowledge. The base knowledge is essential. We cannot depend on base knowledge on domain experts. So we have to get the base knowledge of how it looks like. If this looks like this, next time if it changes, that is an insight, isn't it? I was expecting the number of people below 25 or below 35 in India should be around 40%. But when the census happens, I come to know that it's about 30%. Is it an insight or not? What was your base knowledge? If 35% and below, 35 years and below is 40%. Now the data says that it is 30%. Any difference in what you have believed is an insight that has to be questioned. Is it true? If it is true, what should I do? Right? So either you change your belief, you change your knowledge base, right? You change. No, earlier I thought it is 40%, but for next 10 years it is likely to be 30%, right? But next month itself, if it again changes to 40%, what will you do? Will you change your belief? So if you look at it, last year, because of the census report, I thought that it was about 40% of the people are below 35. So India is a young team. Now the census comes, it says that it is 30%. Last month the census came, it says 30%. There are two options for me. Either I question the source itself, or if the source is extremely reliable, normally I don't rely on government figures because we don't know how much of it is fudged, right? We would like to look at how many have been taken PF and things like that. So those are the actual data we would like to do. But for the sake of things, let's assume government data is correct, right? So I will change my belief. For next 10 years, it is likely to be 30%, right? Now, this month, if the data comes and says, no, it is 40%, that is uncertainty of information. That is the uncertainty of the information, and we should have the base knowledge of the distribution of any statistic that we are measuring. Statistic is nothing but a metric. It may be age of the population, distribution of the age, distribution of the wage, right? Distribution of, let us say, the healthcare index, distribution of the number of infant deaths, distribution of the female infanticide. So any of this can be a distribution about the society. The pay disparity or the pay scale itself, right? How it is different in US, how it is different in UK, how it is different in India. So if we can see, then we can add one more dimension or one more variable. Across sectors, is it same? Right? We can take national average of 8,000 rupees as the base. Is it same across? Will it be same across? Do you think every software will be around that? As of now, the IT and BT are some of the highly paid other than marketing. So in that case, they will be skewing the distribution. You would like to understand that. Anyway, all of this will be handled when you go through the statistics session. But the idea is a visual picture of the distribution is our base knowledge. I want everybody to understand that and start looking at what are the top 10 variables, how they look like. And you will have enough to speak about that when you meet any data scientist or you want to speak. When you don't know what are the base parameters on which you should know the distribution, the problem comes. Then we will be applying monkey see, monkey do kind of thing. I do not want you to be monkey see, monkey do kind of thing. Once you are comfortable, till you are comfortable, you can practice that. But beyond that, you should not use monkey see, monkey do. You should start questioning everything you know. So orange is wrong. The neural network models we are building are wrong. What is right then? What you say is right. So what you say is right only when you have done your homework, and you have to do your homework well. So the first of the things that we are looking at is, how do we see this distribution? This distribution is called as univariate distribution. So it's a hi-fi word. Basically, it is looking at one variable and looking at its distribution, right? We have three variables here. For the, in fact, you not have to consider customer ID, right? Some of you who are working in database, why we should not consider this? Why we should not consider a customer ID, which is a unique value? Why should not consider it? So actually, when I want to analyze, let us say that a swing, I cannot analyze the center. I can analyze the effect of the center outside that center, not the center itself. That center is customer ID. Customer ID, in fact, unfortunately, there are some groups called numerology groups and others, they will change the name also. They say that you change the name, things will change, right? They will analyze that also, right? By taking the alphabets and their position and then adding them, subtracting, dividing, doing something, right? Though it's a pseudoscience, we don't argue about its business value. But the idea is customer ID should never be used. Not just customer ID. Anything that has got unique values or same values should not be used in the analysis. I will give an example. Take gender. When you go to a cricket team, will you analyze how many people are there in All India men's team? How many female are there? Will you analyze it?
No.
Why?
Because the value is same for them.
All are men. It already says it's men, right? It's all are men, right? When all values are equal or when all values are unique, analysis is meaningless. We should understand that, right? So we should know, the first question is it unique or is it same? If the unique or same things are there, drop them. They don't contain any of the information for any analysis. Just drop them, right? That can be done with what we call as univariate analysis. So once we do this, we are seen for all of them. The statistics has been seen. Now I would like to apply my distribution. So if I apply the distribution and put it here, right? We'll wait for some time, it will show. Now see this distribution, right? Now let me select frequency. So what does indicate, right? It contains no information. Now I would like to bin it, how it looks like, right? When I bin it, it tells me about 14,000 people are less than 464 days. All others are more than 500 days, right? So if you say that for your product it should be less than 500 days, then only this group can be taken. If it is less than 1000 days, only these groups can be taken. These cannot be taken. So this becomes the base knowledge. This is a distribution. This is the base knowledge. This has to be understood. Same thing is there with the frequency, right, or monetary. So you can see this, right? This is one analysis, right? Next, I would like to go for understanding where are the okay. So where are my deviations or where are my outliers? What's an outlier?
The overview of any statistics or something, sir.
No, no. You give me very concrete example.
Who doesn't
For
fit the
mangoes,
group?
can you tell me all the mangoes? Let us say that 200-gram mangoes. Every mango will be around 150 to 250 grams. Average size is 200 grams, right? And somebody gives a mango which is 1.5 kgs. One mango weighs around 1.5 kgs. Do you think that mango belongs to the same species as you have purchased last year?
No.
That is an outlier, right? Anything that is not matching with the group is an outlier. So as far as possible, try to find the examples within your kitchen. Always I say analytics is my kitchen. So if you cannot find it in kitchen, outside it may be difficult, right? Then we'll be learning theoretically, but practically we don't know. You should enjoy. You should enjoy when you do analytics and things like that. It must be fun for you. You must accept within kitchen you can do all neural networks. You can do univariate analysis. You can find outliers, right? Everything can be found in kitchen. Same thing. The mango example is one thing, right? So the mango is not ripe after 2 years. Will you call it as a normal mango?
No, no.
Right? Anything that is beyond what we have accepted now as normal can be taken as anomaly. So anomaly will be done with what is called as a box plot. So it says that this is normal. 594 to 1084 is normal. Anything outside is anomaly. Whether we accept them or not is a different question, but this is the anomaly, right? We can analyze this. Once this is done, we would like to analyze, okay, we have done the anomalies within a variable, the distribution of a variable. Now I would like to see, is there a relation between two variables? I can use scatter plot and we'll bring it. Scatter plot is here and we can connect it. The scatter plot looks like this. Okay. Now if you look at the scatter plot, it shows how the x and y axis are related, or they related to each other or not will be visible. Right now if you see, there are only two outliers. Can you see this? Right, this is really outliers, but for us anything that is more than 40, the frequency more than 40 times they are taking, something is abnormal. Check them, right? So these are outliers and this is the relation. Is there any relation? There is no relation between recency and frequency. Now let's check, instead of frequency, if we do monetary, what happens? So now we can see, is there a relation? Whenever frequency increases, is the monetary increasing? Let us change this. Let us take x-axis as frequency and y-axis as monetary. So I will change this to monetary, right? Now you see. Now can you see what is the problem here? When the data size increases, I cannot go on changing my RAM, right? The better thing we will do now you can see, whenever the frequency increases, the monetary value also increases. There is a clear region, right, where we can show the regression line now, how it looks like, right? When I put regression line, it comes there. So we will see how the regression line is working. Now it shows this is what we call as relation. It is linearly related, isn't it? Frequency is linearly related to monetary. It's obvious, but the data also shares so. So if they increase the frequency, increase the monetary, is it true? By increasing it to 140, will it increase? Not necessarily. There are not enough data points to say that by making it more than 40, we are likely to increase the monetary, right? So increasing frequency is not an issue in this particular case. So this is what we are trying to get it, right? So we do scatter plot to analyze the relation between any two variables. Now we want to see this with multiple things, and we will see how it can be done.